Okay, let's start the session. So, hello everyone, welcome. I hope you all are doing good. I am Sambhav, your senior math instructor. Today in this session, we are gonna talk about very important topic, that is trigonometry. Correct? Very important, even from your exam point of view, right? Now, in this session, we are gonna talk about the basics of trigonometry. The chapter name is Introduction to Trigonometry in your books, and then in the next session we are going to talk about the advanced part of it, like the how to find the values of different angles or even different type of problems we are going to see in the next session. So this chapter has been divided in two equal parts. So the first part is all about the introduction. So let's wait for 2-3 minutes so that everyone can join. After that we are going to start the session. So yes, hello to everyone. Welcome. Please join the session. We are gonna start soon. Don't worry. So trigonometry is very advanced branch of mathematics which deals with angles, sides of a triangle. And the name is like that only, trigonometry, correct? You can relate this with triangle in one way. So we are gonna talk about everything, just waiting 1 or 2 minutes. Yes. Yeah. So please join the session. Please, if you are liking this, please give thumbs up. And if you are having any doubt related to this chapter, then you can ask us in the chat box or even in the comment section. So you can ask your doubts. You can let us know what you are thinking, where you are not understanding, what you are not understanding. We are gonna solve it. We are gonna tell you. Okay. Okay. I think it's time that we should start the session. So okay then. So as I told you that in this session we are going to talk about trigonometry. So in this particular session, basically we are going to talk about the introduction part of it, then trigonometric ratios. What are trigonometric ratios? Then we are going to summarize this. So, and in the next session, as I told you that I will be giving you advanced knowledge, how to solve different problems and everything. Now, what is trigonometry? First, we need to understand what is trigonometry. Why the name and everything. So trigonometry is a branch of mathematics, of course it is, that studies the relationship. Look at the wordings here. That studies the relationship between angles and sides of a triangle. In a triangle, the main basic three components are sides, angles and vertex. Correct? So here we are discussing a very specific relationship between angles and the side lengths. Now, particularly in a right angle triangle. So most of the time in your class, we are going to discuss the trigonometry based on right angle triangles only. Now, the word trigonometry comes from, so this word is not a single word, it's a combination of two words. First word is trigonon. So what is the meaning of this word? Triangle. As I told you that this has something to do with triangles only. So this trigonon means triangle itself. Then the second part is metron. Metron means measurement. This word you may have seen in geometry also. Geometron. It means study of the geography or the earth. So the same concept is applied here. Trigonon metrons means study of the measurement of triangle. And very specifically, we are going to study the relationship between the angle and the side lengths of a particular triangle. And in this class, you don't need to be worry about too much of this chapter, because basically we are going to consider right angle triangles, and it is very easy. You may find it hard because this has been introduced for the first time in to you, the trigonometry. That's why it will sometimes feel overwhelming, but it is not. This is very easy. Now, so trigonometry means measurement of triangles. Now, this is about the name and how it came, correct? Now, why do we study trigonometry? Why this is important? Now, trigonometry helps us in measuring heights and distances without physically measuring them. Look at the wordings. Measuring heights and distances without physically measuring them. Now, this is very broad idea. Now, let me ask you one thing. We know what is the height of the Mount Everest, correct? the highest peak. What is the height? We know this, correct? How do we know this? Is someone measuring it using measuring tape? Do they have any tool which they are using to measuring it physically? How are they coming up with the numbers that this is the actual height of Mount Everest? So there was a man named Sir George Everest. So he came up with an idea that we should use theodolites. Theodolite, again a new term to you. Theodolite is a measuring tool which is used to do surveys and everything. It can use trigonometric ratios to find the distance or height of something. So at that time, Sir George Everest, with the help of his team, built two largest theodolites that world has ever seen. Then he placed them at certain distance from the Mount Everest. Then he used trigonometry to find the height of the Everest. That's why the name of the Mount Everest is after him, Sir George Everest. Correct? Those two theodolites are still present in one of the museum in India itself, in Dehradun. So if you want, you can see that also. Those two theodolites are there. Now we have modern theodolites and everything, but still we are using theodolites to do surveys and everything. Now we can use heights and distances we can use trigonometry to find heights and distances without physically measuring them. He is not physically measuring the height of the Mount Everest, correct? He is using a equipment from two sides, and then he is using trigonometric ratios or concept of similar triangles to find the height. Now, understanding the navigation, astronomy, engineering and architecture. So trigonometry is having very advanced use actually. Very vast use of trigonometry is there in this world. So we are using it for navigation, astronomy, engineering and even architecture. So in every branch it is used in some way or another. When you are gonna reach higher classes, you are gonna see that trigonometry will appear in other subjects also, like majorly in physics. Then solving problems involving angles and distances. This is also one of the application. And there is one more interesting application of this chapter. What is that? That we can score easily in the exam, correct? Now, so these are basic applications of trigonometry, although it has a very vast or huge amount of applications. Now, real life examples. What are some real life examples? One example I gave you about Mount Everest. Then we have how can we find the height of a tower without climbing it. Suppose if we are having a tower and if we are afraid of heights, we don't want to climb it, but we want to know the height of that tower, then we can do what? We can use trigonometry. The next chapter after introduction to trigonometry is heights and distances, correct? Or some applications of trigonometry. There you will be seeing the real life applications of trigonometry, correct? You may have seen examples also that some pole is there, it is casting a shadow, one balloon is flying, one kite is flying, and these examples, correct? How can we find the height or distance without physically measuring them? We can use trigonometry there. Then how do pilots calculate altitude? Suppose a pilot is flying a plane or aircraft or anything, then how can they find the height at what altitude they are at? They can use trigonometry. Then how does a surveyor measure the width of a river? As I told you that there are surveyors who are doing survey regarding land, rivers and everything. So they are not measuring everything, no, physically. They must be using some kind of equipment. So those equipments are based on trigonometry. So these are some real life examples. So if you know any similar example, you can let us know in the chat box also. Now, as I told you that this chapter in your class is all about trigonometry dependent on right angle triangles. So first we need to remind ourselves what are right angle triangles, correct? We know them, but let's remind ourselves. Right angle triangle means one of the angle is having exact 90-degree measure, correct? If in any triangle one angle is having exactly 90-degree value, then that triangle is known as right angle triangle, because 90-degree angle is known as right angle, correct? So if one of the angle is exactly 90-degree, then that triangle is known as right angled triangle. According to angle sum property, we know one fact, that the sum of all the angles inside a triangle will always be equals to 180-degree. If one of the angle is exactly 90-degree, can there be any other angle which can be equal to or greater than 90? No, it is not possible. Suppose this angle is 90-degree, huh? Then sum of other two angles would be 180-degree minus 90 itself. So even if this is 1 degree, then it will be 89. So not greater than or even equals to this angle. So this is the highest value. If a 90-degree angle is there, then it is the highest angle present in that triangle, correct? Now, if it is the highest value present in that triangle, then we know for a fact that in case of any triangle, the larger the value of the angle, the greater the length of the opposite side of it, correct? If it is the highest value among the angles, then the side opposite to this angle would be having the greatest length or largest value of length, correct? So this side is the opposite side of this angle B or 90-degree. Then AC is the longest side. Now, if AC is the longest side, then it is having a very particular name, and the name is hypotenuse. So hypotenuse is that side which is opposite to the angle that is exactly 90-degree. Also, it is the longest side present in a right angle triangle. One thing. Now, if we are having hypotenuse, are we having names for other sides also? Yes, we can call them using base and perpendicular, but it depends on what angle we are considering. I will explain this concept also, but understand the basic terminology for now. Base is the side adjacent to the reference angle. Whatever angle I am considering other than this, because we are done with the 90-degree angle, so we are left with two angles now, either angle A or angle C. Depending on which angle we are referring to, we can have base and perpendicular differently. Base is that side which is adjacent to the angle itself. Suppose if I am considering angle C, then the side adjacent to angle C are AC and BC, correct? But it's AC, done, because AC is the longest side, hypotenuse. Then the only adjacent side that is left is BC. It means it is the base now. Then side opposite to this angle C is known as perpendicular. So third side, perpendicular, side opposite, one sec, side opposite to the reference angle. Now let me ask you one thing. Suppose if I am referring to this angle A, will AB be the base or BC? AB is the base. Why? Because this angle A is having two adjacent sides. AC, already we know that it is hypotenuse, and then AB. So base is what? Side adjacent to the reference angle. So AB is the base now. Then what is perpendicular? When we are considering angle A, perpendicular side is BC now, the side opposite, correct? Now, what are trigonometric ratios? First thing, when I told you that trigonometry is the study of relationship between angles and the sides, so what does it mean? It means that we are going to establish a relationship between the angle value and the side lengths, correct? But side length can vary, correct? Suppose if I am having two different triangles, the value of angle can be equal, correct? Value of angle can be equal, but depending on the size of that angle or triangle, the side lengths can be different, correct? So we cannot directly consider the side length. We need to deal in terms of ratio now. Why ratio? Because ratios can be simplified further, correct? Even if we are enlarging a triangle in same proportion, then the value of the side lengths is gonna change, but the ratio of the sides will never change, correct? So that's why we are using the term ratios here. Otherwise, it would have been trigonometric lengths or trigonometric sides, correct? Why ratio is there is because we cannot consider the length exactly as it is. Otherwise, we need to deal with very large amount of data depending on the different side lengths, correct? But we are going with ratios now. So this way we can solve this problem even if we are having different lengths in a triangle, but we can deal with them easily because we can find the equivalent ratios. Now, trigonometric ratios are ratios of the sides of a right angle triangle. So the ratios is of sides now. Angles can be equal, so no need to find the ratio of angles, but we can find the ratio of the side lengths. It means we are dividing at least two sides. We are writing them in a fractional form, correct? So it can be AB by BC, it can be AB by AC, BC by AC, like that, or reciprocals also. Now, with respect to a given angle, so whatever angle we are considering, depending on that angle, we can have different base, different perpendicular, correct? Depending on different base and different perpendicular, we can have different trigonometric ratios value. I will explain this in detail. They depend on the angle. What is the value of the angle, correct? Then the ratio, not the actual length. I told you what is the reason behind not using the actual length. If we are using actual length, then we need to deal with very large amount of data, and that will not always be very accurate. So that's why we are going with the ratio thing. We are gonna talk in terms of ratio of two sides. Now, why ratio? If two triangles have the same angles, then their sides are in proportion, correct? Suppose two triangles are there and they are having different sides, but the internal angles are having same measure. The corresponding angles are having same measure, such as 30-30, 60-60 and 90-90, correct? So all the corresponding angles are in same ratio. In sixth chapter of your class, the triangles, you may have understood the concept of similar triangles, correct? Then according to similar triangles, if two triangles are having all the corresponding angles equal, then the two triangles are similar to each other, or it means that their corresponding sides are in the same ratio. So this concept we are applying here. That's why we are going with the ratio. So trigonometric ratios depends only on the angle, not on the size of the triangle. You can increase the length of the triangle, increase the side lengths, but if the angle value you are not changing, then they will always remain in the same proportion, correct? Now, this concept that I explained, now I explain again. Depending on which angle we are referring to, we can have different base or perpendicular value. So other than base perpendicular, we can also refer them as side opposite or side adjacent. So there are two ways to referring the sides now. You need to understand both of them. Now, hypotenuse will remain hypotenuse, the longest side, correct? Side opposite to the 90-degree angle is hypotenuse. Then suppose in this figure I am referring to angle A. Triangle is triangle ABC. B is right angle. So AC is the hypotenuse. Correct? I am referring to angle A now. Then as I told you that for angle A there are two adjacent sides. AC already hypotenuse. Then the other side is AB. So this will be called as side adjacent to angle A. Correct? Then the side opposite, which is not adjacent with this angle A, is known as side opposite to angle A. Now, this is when we are referring to angle A. Suppose if we are referring to angle C, will it be same? The side adjacent will remain same only? No, it will not. It will change now. Hypotenuse will remain the same because hypotenuse is not changing. AC is again side opposite to the largest angle B. So now, if angle C is given or angle C is what we are referring to, then the side adjacent would be BC because this is already hypotenuse. Then BC is the side adjacent now to angle C, and side opposite to angle C would be AB. So you need to just realize this again. If side opposite to angle A is BC, then BC is the perpendicular when we are talking about angle A. If side adjacent to angle A is AB, then AB is the base in this case. And in this case, it is exactly the opposite. If we are referring to angle C and BC is the side adjacent, then it is the base side. And what is the perpendicular side? Side opposite. Very basic concept, correct? Now, these are trigonometric ratios. So initially, I guess Aryabhatta was the one who referred to this sine value first. So Aryabhatta was the one who gave the sine value. He told that the value of sine will always be equals to perpendicular by hypotenuse. In Sanskrit, they are known as Jaya, Trijya, like these words. So he referred them in such a way. Then later on, they named it as sine. But according to Aryabhatta, it is Jaya, I guess, if I'm not wrong. But Aryabhatta was the one who gave away this concept first. Then later on, they built these cosine, tangent, cosecant, secant, and everything. Majorly, there are only three trigonometric ratios: sine, cosine, and tangent. These three are nothing but the what should I call them? I'm forgetting the name. Okay, I will remember the name again. But these three are the mean ratios, and you will understand why also. Sine is the relationship between the angle with which side perpendicular divided by the hypotenuse. So depending on what angle you are referring to, sine value will always be perpendicular by hypotenuse. Now look at this triangle ABC, right angled at B, correct? So this is 90 degree. Let me change the color of the pen now to black. So right angled at B. So this is 90 degree angle. Then side opposite to 90 degree angle is the hypotenuse. So it means AC is the hypotenuse. I will use the initials only. H for hypotenuse, B for base, P for perpendicular. Okay. Now, so this is hypotenuse. Then suppose if I'm referring to angle C as the angle, then sine value, SINE is the proper word, but when we are writing, we can use SIN with the theta or whatever angle. It can be A, B, C, not B. It can be A, C, or it can be alpha, beta, gamma, anything. Now, you can write it like this, SIN and the angle name. So, if we are going with angle C, then perpendicular by hypotenuse will be the sine. What is perpendicular now if we are referring to angle C? Perpendicular is the side opposite to the referred angle, correct? Which side is the opposite side to this C? This AB. So, this is perpendicular. Then which side is base? BC. So BC is the base. Then what is sine theta if we are referring to angle C? P by H or AB by AC. Then cosine, complementary angle of sine. So cosine is basically complementary angle of sine. We know the concept of complementary angles, no? When two angles are having exactly measure or sum equals to 90 degree, then they are known as complementary angles. Now, look at this triangle, right angled, correct? One of the angle is 90 degree. Then this angle and this angle, are they complementary to each other? Yes, they are, because their sum will always remain 90 degrees, always. Now, this concept later on used to develop the other three trigonometric ratios. So sine is there, then someone thought about the complementary of sine, it became cosine, usually written as cos. You are gonna write cos along with theta or whatever angle you are referring to. And what is the value of cos then? Base by hypotenuse. What is happening here? How come it be base by hypotenuse? As I told you that cosine is the complementary angle of sine, correct? Suppose if someone is considering or referring to angle C, then what is the complementary angle of angle C here? Angle A, correct? What is the sine value for this angle A? That would be perpendicular, but according, if we are referring to angle A, then the perpendicular is BC and hypotenuse is AC, correct? Now, but angle A is the complementary angle of angle C. So if we are finding the trigonometric ratios in terms of complementary angles, then the complementary of sine would become cosine, cos. So cos C value will be same, BC by AC. But now I can see C here, no? And with reference to C, BC is not the perpendicular, it is the base. So that's why cos value will always be base by hypotenuse. Because if I am finding the sine value in the corresponding angle, then the base will be different. So that's why cos is base by hypotenuse now. Then tangent. What is tangent? Tangent is basically the ratio of sine and cosine. Sine divided by cosine. Okay, let's do the math now. If I am saying that tangent is sine divided by cos, so let me do it. Tan theta is sine theta by cos theta. This is the value, correct? Sine theta is P by H and cos theta is B by H, base by hypotenuse. H and H we can cancel. So what are we left with now? P by B. So that's why the value of tan theta or tangent theta is perpendicular by base. Depending on what angle you are referring to, the ratio of perpendicular by base will always give you tan theta. Suppose if we are considering or referring to angle C, then perpendicular to angle C is AB and base is BC. So tan theta would be AB by BC. Now these three are the main trigonometric ratios. Other three are nothing but the reciprocal of these ratios, like cosecant. Cosecant is the reciprocal of sine theta. So cosecant value is 1 by sine theta, or in terms of side ratio, it would be what? 1 by perpendicular by hypotenuse. 1 divided by any fraction, we need to take the reciprocal of the fraction, correct? So the fraction will become hypotenuse by perpendicular. So cosecant theta is hypotenuse by perpendicular. Then secant theta is nothing but the reciprocal of cos theta. So secant theta is 1 by cos theta. Cos theta is base by hypotenuse. 1 divided by base by hypotenuse will become hypotenuse by base. So secant theta is h by b. Cotangent is reciprocal of tangent. So what is the value? 1 by tangent. Tangent is perpendicular by base. So 1 by p by b is gonna give us b by b or base by perpendicular. These 6 are the trigonometric ratios that you are gonna deal with in your whole life. If you are dealing with trigonometric ratios, then you must be dealing with them only. Majority of the time, you are not gonna write their full names. You are gonna use them in short form, like sine theta, cos theta, tan theta, cosec theta or cosecant theta, secant theta, and cot theta. These are the names that you will be using. Now, there is a memory trick to remember this. There are multiple tricks. but you can go with this also. That is, some people have curly brown hair till painted black. Why this is a memory trick? Look at the initial of each word. Some people have. I did color them in a single color, blue, so that you can see easily. Now, some represent S. People have is P and H. So S is equals to P by H. You need to understand it like this. What does S stands for? Sine theta. S is sine theta. What is P? Perpendicular. What is H? Hypotenuse. So sine theta is perpendicular by hypotenuse. Then look at this one. Curly brown hair. It means C is equals to B by H. What does C stands for? Cos theta. So cos theta is base by hypotenuse. Curly brown hair. Then third part, till painted black means T is equals to P by B. T stands for tan theta. Tan theta is perpendicular by base. What about the other three? The three that we are left with. We know that cosecant theta is 1 by sine, correct? Easy. Then secant theta is 1 by cos, and cotan or cot theta is 1 by tan. Now you can remember easily. So the trick is, some people have curly brown hair till painted black. So we are going to use the initial of each word in a pair of three. So three words. So S, P, H. It means S equals to P by H. Sine theta is equals to perpendicular by hypotenuse. C, B, H. C is equals to B by H. Cos theta is equals to base by hypotenuse. T, P, B. Tan theta is equals to perpendicular by base. This is the trick. Remember this. If you want, you can take the screenshot also, so that it will be very much helpful for you, or take a note of it. Very easy to remember. Now we can take 5-minute break. After this, we are gonna solve different problems that you can expect based on trigonometric ratios. What type of problems examiner can give in the final board exams, and also how to approach them, so that you can get the full marks easily. Okay, I will tell this. So take a 5-minute break. I will come. Okay, let's start the problems now. So till now we have understood the basics of trigonometry. Why the name trigonometry? Trigonon, metron. Trigonon means triangle and metron means measurement. So measurement of triangles. So trigonometry is basically branch of mathematics which deals with the study of relationship between the angles and the side length of a triangle. In your current standard, we are gonna deal with the right angle triangles only. So a study where we are having different sides. So in a right angle triangle, there are three sides possible depending on which angle we are referring to. That is hypotenuse. Hypotenuse will always remain same side only because hypotenuse is the longest side, that is side opposite to the largest angle 90 degree. Then other sides can be perpendicular and base depending on which angle we are referring to. Correct? Now we have seen different types of trigonometric ratios like sine theta, cos theta, tan theta, cosecant theta, secant theta, and tangent, cotangent theta. Correct? What is sine theta? Perpendicular by hypotenuse. Again, depending on which angle we are referring to. What is cos theta? Cos theta is base by hypotenuse. Tan theta is perpendicular by base. Then cosecant theta is reciprocal of sine theta, so its value is hypotenuse by perpendicular. Then secant theta is reciprocal of cos theta, so its value is hypotenuse by base. Then we have cotan theta. Cot theta is actually reciprocal of tangent theta, so its value is base by perpendicular. So this we need to remember. There is a trick also that I told you, that some people have curly brown hairs till painted. So initials you can use, correct? Now let's look at different type of problems that you can encounter in this chapter. First problem is in a right angle triangle ABC. Okay, right angle triangle is given to us. Sometimes the figure will be given, sometimes it will not be given. So you can do one thing, you can always create a figure on your own for your reference only. Figure will give you more confidence. What you are dealing with, you can visualize easily. So always do this thing. If you are ever confused what to do now, how to approach the problem, first create the figure. Okay, if it is not given, then right angle at B. Okay, so B is the right angles, and then which side is the hypotenuse? AC, the side opposite to right angle. Now AB is equals to 6 centimeter. Okay, length of AB is given to me 6 centimeter. BC is also given to me 8 centimeter. We need to find sine A, cos A, tan A. Now this is very easy problem. If you are thinking how to find this, or how should we approach this, then first thing, what things do we need when we need to find these trigonometric ratios? What are the things we need? First thing, sine A is, let me write, sine A means that we need to find the ratios of those sides which are referred when we are considering angle A. So sides we need to consider when we are referring to angle A, because sine A means we are considering angle A, and sine value will always remain same depending on what angle we are considering, the perpendicular by hypotenuse of the triangle. So which angle we are referring to? Angle A. So let me put a mark here. Now it is perpendicular by hypotenuse. Which side is perpendicular when we are referring to angle A in this triangle? Okay, this AB is the side adjacent, correct? Adjacent side. So adjacent side will always be base. So this is base. Then perpendicular side would be side opposite. So this side is perpendicular, BC. Okay, length of perpendicular we know. What about hypotenuse? Do we know the length of hypotenuse? No, it is not given directly to us. Why I am saying not given directly? Is there any way that we can find this length? Yes, we can find this very easily. We know the concept of Pythagoras theorem, correct? So, according to Pythagoras theorem, the square of the hypotenuse in a right angle triangle will always be equals to sum of the squares of other two sides, correct? So, first let's find the value of hypotenuse here. According to Pythagoras, one second, let me erase this. First, we are going to find the length of hypotenuse using Pythagoras theorem. So, hypotenuse square will always be equals to sum of squares of other two sides. It means h square is equals to p square plus b square. These two values we know, 6 centimeter, 8 centimeter. So, perpendicular is 8 centimeter. So, 8 square, base is 6 centimeter, 6 square. 8 square 64, 6 square 36, sum 100. But this is not h, this is h square, correct? Then what is the value of h? Under root 100. Do we know the value of root 100? Yes, 10 centimeter. So it means hypotenuse is 10 centimeter. Now we know everything, correct? So let's erase this. Now we can easily find the ratios. So the first part here is, if a problem like this is given to us, so first we need to calculate the remaining side. Sometimes examiner can give you the value of base and perpendicular, so you need to calculate the value of hypotenuse. Sometimes he can give you the value of hypotenuse and one of the other side. Then you need to calculate the remaining one. So the formula will remain same. Pythagoras theorem, h square will always be equals to p square plus b square. So whatever side is not known to you, you can calculate easily by transposing the terms accordingly, correct? Now we know all the values. So sine theta or sine A in this case would be P by H. Perpendicular BC, hypotenuse AC. Length of BC 8, length of AC 10. But this can be simplified further, correct? So the final value would be 4 by 5. So sine A is 4 by 5. Easy, correct? We just need to find the length of hypotenuse, then we can easily find the sine. Now, cos A. Remember, some people have SPH, some people have curly, means cos, brown hair. So, cos A would be B by H or base by hypotenuse. If we are considering or referring to angle A, then base is AB. AB, hypotenuse is hypotenuse AC. Length of AB 6, length of AC 10. But this can be simplified further. So 3 by 5. Because these are having one common factor 2. So we can eliminate that and we are left with 3 by 5. Now to find tan A, there are two ways. As I told you, tan A is nothing but the ratio of sine A by cos, correct? So that way also we can find, or otherwise we can use the ratio directly. Some people have curly brown hair till T, painted P, black B. So tan A is P by B, perpendicular by base. Perpendicular 8 centimeter, base 6 centimeter. But this can be simplified further, correct? So 4 by 3. Even if we are going with sine theta by cos theta, then 4 by 5 divided by 3 by 5. 5 and 5 cancel. We are again left with the same answer, 4 by 3. So there are two ways to find the value of 10, but my suggestion would be that go with this. Tan A is equals to P by B, correct? So this way you can approach this problem and you can find the solution. First you need to find the value of hypotenuse, then only you can move ahead, correct? Now if sine theta is equals to 5 by 30, where theta is acute, find cos theta and tan theta. Now, different type of problem, but we need to find the trigonometric ratios again. But here, the problem has been written differently. Value of sine theta is given to us. Now, it is asking us to find the value of cos theta and tan theta. What is sine theta? Some people have S is equals to P by H. So, sine theta is equals to perpendicular by hypotenuse. Value is already given 5 by 30. So, we can relate, correct? So, 5 is value of P, 13 is value of H. So, suppose this is the angle, this is theta. The perpendicular with reference to angle C is what? AB. AB is 5. Please don't write centimeter in front of 5. Why? Because this is not the exact length. It can be a simplified fraction. This is related to this perpendicular, but this is not the actual length. Or we are not sure that it is the actual length, but this is the ratio, no? So we can use 5, but we cannot write centimeter in front of it. Hypotenuse is 13. When we are enlarging or shrinking a triangle, then their ratio will not change, correct? The concept of similar triangle. But we are not sure if the lengths are exact. But we can use these values to find the other remaining values. That we can do. Now, we know the length of hypotenuse, we know the one of the sides. How to find the remaining one? How to find this value? The formula will remain same. H square will be equals to P square plus B square. Means hypotenuse square will always be equals to perpendicular square plus base square, or the sum of the squares of other two sides. Now, this value I know, this value I know, this I don't, but I can easily find, correct? So, in place of H, I will write 13 square. In place of B, 5 square plus B, I want to know. 13 square is 169. 5 square 25. B square we don't know, so B square as it is. When transposed to left side, this 25, so it will become a negative term. So 169 minus 25, it will be 144 is equals to B square, which suggests that B is under root of 144, and 144 is the perfect square of 12, so under root 144 is 12. So BC is 12. Now we know all the three sides, correct? Let me erase the unnecessary part from the screen. Of course, you need to write this in your exam sheet and no need to erase from there. Otherwise, an examiner is gonna think that you are cheating and he will deduce some marks. So don't write these from your main mark sheet. Okay. Now we know all the sides, correct? In terms of ratio, not the exact length, but they are pretty much useful. Sin theta we already know, we need to find the value of cos theta. So cos theta is curly black here. B by H. Base value is 12 now, because theta is here, no? Side adjacent is the base, so 12. Hypotenuse is hypotenuse. They are co-primes, it means they are having no common factor. So this is the final answer. What about tan theta? Tan theta is what? Perpendicular by base. So perpendicular here is 5 and base 12. Again co-primes, this is the final answer. So this is how you can approach this type of problems, but be very careful, no need to write centimeter in front of these values because they are ratios, not the actual lengths. But they are pretty much useful in solving this type of problems. If any specific trigonometric ratio is given, then you can utilize that information. Okay. Now, third one. What is given to us now? If cot theta is 7 by 8, we need to evaluate 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. A very different type of problem, but still in exam you can expect anything, correct? But don't worry, this is also very easy. This is even easier than the previous ones. You are gonna help me in this. Okay, what is given to us? Cot theta is 7 by 8. We know cot theta is nothing but the reciprocal of tan theta. It means it is 1 by tan theta. Tan theta is perpendicular by base, correct? So it will become 1 by perpendicular by base. Ultimately, it will become base by perpendicular, correct? So cot theta is base by perpendicular, or this ratio that is given to us belongs to b by b. So in this triangle, first we can consider any angle to be theta. Suppose if I am going with this is my theta, then we are looking for this ratio b by p. So base would be BC, then side adjacent, the value is 7, not centimeter, 7. And perpendicular is side opposite, so AB is the perpendicular, value is 8, again not centimeter. Now this information is useful because now we know the value of at least two of the sides. If we know the value of these two sides, can we find the third side? Of course we can. Now let me erase this thing. No need to erase this from exam sheet, huh? So we need to find the length of hypotenuse. According to one of the greatest mathematician, Pythagoras, or one Indian mathematician is also there, Bodhayan, who gave away this theorem, Pythagoras theorem, even before Pythagoras. Hypotenuse square will always be equals to sum of the squares of other two sides, correct? Now h square is p square plus b square, correct? H square we don't know, we need to calculate, so I will keep it as it is. P square is 8 square plus b square is 7 square. 8 square is what? 64. 7 square 49. Sum is 113, right? 60 plus 40, 100. 4 plus 9, 13. So 113. This is value of h square, not h. Then what is h? Under root of 113. Now you must be thinking that it should come in a perfect square root value. It should be something like a whole number, correct? But that is not always the case, correct? If you are getting this type of value, don't worry, this can be the answer. Now we know the length of hypotenuse, that is in roots. I will keep it in roots only. Under root 113. So let me erase this. Now we know all three sides, correct? Base, perpendicular, hypotenuse. And we need to evaluate, or we need to finally find the value of this. 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. There are two ways. Either I can directly multiply them. How? Because this looks like to me a plus b into a minus b, correct? A plus b into a minus b, identity, that will be equals to a square minus b square. Same goes for the denominator, correct? There also this identity is applicable. Or we can put values first, then we can apply the identity. So which two values do we need? Which two trigonometric ratios do we need here? Sine theta and cos theta. So first, let's find the value of sine theta and cos theta. Here I will do this. Okay, sine theta. P by h, perpendicular by hypotenuse. Perpendicular is 8, hypotenuse is root 113. So 8 by root 113. Then cos theta is base by hypotenuse. It means 7 by root 113. Now we know the value of sine theta and cos theta. That is all what we need to evaluate this. Correct? Now, put the values in the given expression. So the expression will become 1 plus, in place of sine theta, 8 by root 113. 1 minus 8 by root 113 divided by, in brackets, 1 plus 7 by root 113 and 1 minus 7 by root 113. Correct? Now we can apply the identity a plus b into a minus b. It will become a square minus b square. So in numerator, that will be 1 square minus 8 by root 113 whole square. And in denominator, again the same identity is applicable. So a square means 1 square minus 7 by root 113 whole square. Now we can open the squares. So let me split the screen so that we can use this space. 1 square is 1 minus 8 by under root 13 whole square, under root 113 whole square. 8 square would be 64 and square and under root in the numerator will cancel each other. So it will become 1 minus 64 by 113. And in the denominator of the whole expression, 1 square would be 1 minus 7 square 49 divided by under root 113 square 113. Now we can take LCM in denominator and numerator both. So upper side will become 113 minus 64 by 113 and whole divided by, here LCM again, 113 minus 49 divided by 113. We can cancel this value. Anyway, this is problematic. 113 minus 64 is 49 divided by 113 minus 49 is 64. Are they having any common factor? Are they? No. This is your final answer. This problem is very easy, but the main part is that we need to write down too many steps, but that is not a problem, correct? Because these are very easy calculations. So we are just following the previous step to find the other one. Just doing the basic math calculation, square, under root, plus, minus, multiplication, division. That's it. So this is how you can find the value, correct? Even though we are getting the value of h in under root, it is not a perfect whole number, but still we can easily find the answer, correct? Now, next problem. Again, one different type. If 3 cot A is equals to 4, check whether left side 1 minus 10 square A divided by 1 plus 10 square A is equals to cos square A minus sin square A. These type of problems can also be solved using trigonometric identities, which we are gonna discuss in the next session. But they are also solvable using trigonometric ratios. But the ratio is not given to you. The value that is given to me is 3 into cot A is equals to 4. How can we use this to make it a ratio or to find the the length of sides in terms of ratio? First thing first, if you are getting confused, then draw the figure. Any triangle you can draw, right angled triangle. Suppose this is A, B, C. What do we understand by 3 cot A is equals to 4? When the value of cot A being multiplied with 3 is gonna give us 4. One way of thinking like this. Suppose if I transpose this 3 to right side, what will it become? Cot A is equals to 4 by 3. Now does it look like a trigonometric ratio? Yes, it is looking like a trigonometric ratio. What is cot A? 1 by tan A, correct? So it means the value of cot A is base by perpendicular. Okay, this till now I have been considering this angle to be theta, no? So here the angle A is given, so it means we need to consider this angle. Be very careful about this. Whatever angle is given, you need to consider that angle only in the figure. Now, what is the side that is base now when we are referring to angle A? So base is side adjacent, so this is my base. So the value of the base is 4, not centimeter again, very careful. Value of perpendicular side opposite is 3. Can we find the value of hypotenuse? Of course, we know how to find it using Pythagoras or Bodhayan theorem. So that would be h square is equals to p square plus b square. H square is not known to us. We will keep it as it is. P square means 3 square, 9. Directly I am writing, but in your exam, you need to write every step. Huh? B square is 4 square, 16. So h square is 25. H is root 25. We know this, correct? 5. So the value of this side is 5. Anyway, let me give you one hint. If out of these three, any two values are given as side of any right angle triangle, then the other one will always be the missing value. 3, 4 and 5 are nothing but the Pythagorean triplets. They are known as Pythagorean triplets. So if two sides are 4 and 3, then the third one would be 5 only. If two sides are 5 and 4, the 5 and 3, then the third side would be 4 only. For 5 and 4, the third side would be 3 only. They are Pythagorean triplets. Now, we know all the side lengths, not the exact values, but their ratios, correct? So now how to approach this? 1 second, I need to erase everything so that we can move ahead. Second. We need to verify this relationship, correct? So if we need to verify this relationship, first I need to find the values of tan. Here only tan is needed, and here cos and sin. Now let's find the values. I'm gonna write the values here. I'm gonna use this space. So tan A perpendicular by base. So it means 3 by 4. Sin A perpendicular by hypotenuse. It means 3 by 5. Cos A base by hypotenuse. It means 4 by 5. Now we know all the values, correct? So we can put the values here. So first I'm going with left hand side. 1 minus tan square A, it means 1 minus 3 by 4 whole square. Divided by 1 plus tan square A means 1 plus 3 by 4 whole square. This is gonna give us 1 minus 3 by 4 whole square means 9 by 16, correct? 1 plus 3 by 4 whole square means 9 by 16 again. Take the LCM. So the numerator will become 16 minus 9 by 16. Divided by the denominator will become 16 plus 9 by 16. Right? These 16s are cancelable. So we are going to cancel them. So 16 by 9 in numerator. 7 divided by 16 plus 9, 25. So the LHS is 7 by 25. You can write the solution like this only. First, we are going to solve for LHS. Now consider RHS. RHS is cos square A minus sin square A. So cos square A means 4 by 5 whole square minus sin square A means 3 by 5 whole square. Four by 5 whole square, 16 by 25 minus 3 by 5 whole square, 9 by 25. They are having same denominator, so we can easily perform the operation, correct? So it will become 16 minus 9, that is 7 by 25. Are they equal? Yes, they are. They are equal, correct? So it means this is true. So the given equation is true for all the values of angle A that you need to write in the end. Okay, now this is one type. Next one. In triangle ABC, right angled at B, if tan A is equals to 1 by root 3, find the value of sin A cos C plus cos A sin C. Okay, now this time we are dealing with a different type of problem. Till now we are dealing with those trigonometric ratios where we are only referring to one angle, correct? If we are talking about angle A, so angle A only. Talking about angle C, so angle C only. But this is the first problem where we are gonna, sorry. So this is the first problem where we are gonna refer to two different angles, angle A and angle C also. So be very careful about the values here. Whatever value of sin A will, it cannot be always equals to value of sin C because we are having different angles now. But still we can solve this very easily. How? Tan A is given as 1 by root 3. Tan A is 1 by root 3. Now, what is tan A? Perpendicular by base. So it means this is P by B. So tan A means we are referring to angle A, this angle. So with respect to angle A, the value of perpendicular is 1. So perpendicular is side opposite. So this is 1. What is base now? Value is root 3, but with reference to angle A, the base is side adjacent. Correct? Can we find the value of hypotenuse? Yes. So we can use h square is equals to p square plus b square. Now h square would be perpendicular square 1 square plus root 3 square. H square would be 1 plus root 3 square 3. H square is 4. Therefore, h is under root 4, that is 2. Now we know the value of hypotenuse, 2. Now we are done finding all these side lengths, not exactly the length but the ratios, correct? So we can, I will erase this. You don't need to erase this part from your exam sheets. Now we can approach the problem. So what do we need to find? First we are gonna find the values. Prior to solving the equation or expression, we are gonna find the values first. We need sin A and cos C, correct? So I'm gonna write the values here. Sin A. With respect to angle A, we need to find the ratios of P by H. P is perpendicular, so 1 by H 2. 1 by 2. Then cos A. Cos A with reference to angle A, which side is the base? AB. Root 3. Hypotenuse, same, 2. Then we need sin C and cos C. Sin C. Now the angle that we are considering is different. So sin C is, it means we are referring to angle C. Which side is side perpendicular when we are referring to angle C? AB. So sin C would be root 3 by hypotenuse 2. Then cos C. When referred to angle C, which side is the base? BC. Divided by hypotenuse 2. All the values are known to us now. Now, put them in the expression. Sin A means 1 by 2 into cos C. Cos C is this 1 by 2 plus cos A. Cos A is root 3 by 2 into sin C. Sin C is root 3 by 2. Multiply these two and these two. 1 by 2 into 1 by 2, 1 by 4 plus root 3 into root 3, root 3 whole square. So 3 divided by 2 into 2, 4. Having common denominator, same denominator, so we can directly apply the operation. This is going to give us 1 plus 3, 4 by 4. So the final answer is 1. This is the final answer. And this is how we need to approach this type of problem. Be very careful about this type of problem because the angles are given differently. So the values will change accordingly, correct? Now, sixth problem. In triangle ABC, right angled at B, again right angled at B, if AB is 5 centimeter, so length of AB is 5 centimeter, this time it is given the specific length, not the ratio. And BC plus AC is equals to 25 centimeter. Oh, this one is a little bit tricky. Why? Because you will get confused how to approach this problem now. The length that is given to us is BC plus AC. Not of BC, not of AC, but their sum. What to do now? Okay, do one thing. Let's consider the length of AC to be x. Correct? Then what is the length of BC? AC minus, 25 minus AC, correct? From this equation, BC would be 25 minus AC. AC we are considering as x. So the length of BC will become 25 minus x. Correct? But still, the problem is not solved because now we are having the length of the sides in terms of algebraic expression. What to do now? Apply the Pythagoras theorem. Now only. So, hypotenuse square is equals to P square plus B square. Hypotenuse is x. So, x square is equals to any side you can consider as P. So, I am going with 5. 5 square. So, base will become 25 minus x whole square. X square as it is 5 square 25. Here I can apply the identity a minus b whole square. So a square means 25 square 625 plus b square means x square and minus 2ab means 2 into 25 50x. Now look at this, x square and x square we can cancel them. And this minus 50x I will bring to left side. So will become positive term 50x. 25 plus 625, 650. So x will be 650 divided by 50. 0, 0 cancel. 65 by 5, 13. Now I know the value of x, 13. Then what is the value of 25 minus x? 25 minus 13, 12. Now we know all the side lengths, correct? Not a problem anymore. We need to find what? Values of sine A. So let me erase this. So now the problem is very easy. So the only difficulty here is that the actual values are not given, but instead we need to apply the concept of algebraic expressions here to find the values of each side. Sine A, it means we are referring to this angle. Sine A is perpendicular by hypotenuse. Perpendicular 12, hypotenuse 13. Then we need to find cos A. Cos A, we are referring to the same angle B by H, base, that is AB, 5 centimeter, by hypotenuse, again 13. Now we need to find cosecant C. So it means we are referring to this angle now, cosecant. Cosecant theta or C would always be equals to 1 by sine C. It means reciprocal of sine C. Sine is perpendicular by hypotenuse. 1 by sine C would become hypotenuse by perpendicular. So for cos C, hypotenuse is same 13 by perpendicular. Which side is perpendicular when we are referring to angle C? AB. So it will become 13 by 5. Correct? Then secant C. Secant C is nothing but reciprocal of cosecant, 1 by cos C. Cos is B by H, base by hypotenuse. 1 by cos C would be H by B, hypotenuse by base. So for secant C, when we are referring to angle C, which side is hypotenuse? Same side, 13. And base would be this, 12. So these are the answers. This is how you can approach this type of problem. Understood? So yeah, these are the major type of problems that you can expect from trigonometric ratios only. So in this session, we understood the introduction part, introduction to trigonometry. Then we understood trigonometric ratios, which ratio, how to find them, how to memorize them. Remember the memory trick. Some people have curly brown hair till painted black, correct? That you can apply, and different type of problems we have seen, correct? So this is how you can approach. In the next session, what can you expect? I will tell you how to create this table. You may be familiar with this, correct? This is very useful because these are the angles that we are dealing with in 10th class. 0, 30, 45, 60 and 90. How to find the values of specific angles. So sine 30, sine 45, sine 90, cos, cosecant, how to find these values, I will tell you. How to create this table easily, I will tell you a trick also in the next session. So for now, let me just conclude the session. So yes, we understood the basics. We talked about trigonometric ratios. For now, I will take your leave. So in the next session, we are gonna continue our discussion on trigonometry, where we will be talking about trigonometric identities and values of some specific angles. So till then, bye bye from my side. Please take care. We'll meet you in the next session.